So we're going to work on arm and leg measurements, and I'll go through some of the problems on the first page. The second page is kind of identical. It's just a new data set. This is real Emory High student data of measurements from elbow to fingertip and top of your kneecap to, what was it, heel to the floor. Yeah. So you have all 50 data pairs. You can see the x average, y average, SDX, SDY, R value. Oh, they're on there twice. That was really smart of me. And then you can see the scatter plot. Now, wait a minute. If you count that up, that's not 50 points. How come you don't see 50 points? Some are right on top of the others. We treated this as a discrete qualitative variable. And in reality, lengths are not discrete, but we only measured them to within the nearest quarter inch. Okay. So, number one, what percentage of males are expected to have an arm measurement of 18 inches or more? First of all, I'm only allowed to do this if my x's are normal. How do I know that my x values are normal? Because the scatter plot is football shaped. If the scatter plot is football shaped, then the x's are normal and the y's are normal. Okay, if it was a peanut or a circle, you can't really do anything with it. Or if it was like a megaphone shape or something like that, or a U-shaped, then we can't do this. So my x average is 18.47, and I want to know what percentages of males are 18 or higher. So if that's 18 and I shade to the right, what do I need to do? Well, I definitely should shade norm because my answer is a shading. What do I need in order to shade norm? Just give it up. There's no point. What do I need in order to do a shade norm? I need the z-score for 18. How do we find z-score? We do value minus average over standard deviation. So 18 minus 18.47 divided by 1.1. So 18 minus 18.47 gives me negative 0.47. Divide that by 1.1. And what does negative 0.427 tell me? It's the z-score, but what does the z-score mean? That's how many SDs this person is below average. So go to shade norm, and I'm going to shade norm from negative 0.42727. How high do I want to go? 5 or any number higher than 5 will work. Oh, oops, whatever. I'll still get the right answer. And I get 66.5%. Okay. Now this is going back to chapter 5. Okay. Number 2, 60% of males have leg measurements higher than what value? So here's my curve. This is 18.47. I want to shade an area that represents 60%. So where is my z going to be? Is it going to be right of the average or left of the average? So it says have leg measurements. Oh, it's not. Sorry. It's not 18.47 because we're doing leg. If I want to do higher than what value, then I need to put that value on the left and have this equal 60%. Okay. Now what? Who's confused? So I want a value that says 60% of males have leg measurements higher than what value? So I want some y value that represents the spot where 60% of the people are bigger than that number. Okay? So how do we do this? Well, if the right tail is 60, then the left tail is 40. Then what do? I do 40 on the other side, which means the center, well, that's if you go +1 and -1. But we're saying the right side from this line over is 60%. So the left side is 40 and the right side is 40, which means the center is 20. What do I do with that number? Go to the z-score table, and I look at 0.2, which is right between 0.24 and 0.26. So my z is negative 0.26, or 0.25, sorry. Okay, does anybody not understand that? You still confused? She's healed. Okay, what does that tell me? %60 of the men had leg measurements that are 1/4 SD below average or more. Does that make sense? 60% of the males had leg measurements that are 1/4 SD below average or more. Okay, what do I do with this z-score? I need to, well, I can't shade norm. I started with a shading, right? So if I shaded norm, I'd get 60%, which is back to where I started. I need to turn them into inches. How do you turn a z-score into inches? You times it by the SD. So we're going to multiply by 1.45. So negative 0.25 times 1.45. What does that number tell me? A person who is at that 60% or more line is about a third of an inch shorter than average. So how do I figure out how tall that person is? Add it back to the average of 21.8, and I get 21.44. Does that make sense? So if you have a leg measurement and you're male of 21.4, 60% of the people had a measurement higher than that. Okay? Is this kind of coming back? All right, number 3. If a male student has a leg measurement of 20.5, what percentile would he be? So, draw the graph. And this is 21.8. And right here is 20.5. And we want percentile. And percentile is always left area. My answer is a shade. So I need to use shade norm in this case. To calculate a z-score, I do 20.5 minus 21.8. What does negative 1.3 tell me? This person is 1.3 inches shorter in leg measurement than average. Okay. Now I need to turn that into a z-score. So I divide it by 1.1. That's the SDX. Or no, we're doing leg, huh? Sorry. Negative 1.3 divided by 1.45. And I get negative 0.89655. What does that mean? This person is about 9/10 of an SD below average in leg measurement. So I do a shade norm. What do I put as my lower bound? I can leave it. If you don't have this kind of calculator, what are you going to put as your lower bound? -5 or -6. Anything smaller than that will work. And I'm going to go up to -0.89655 and then draw my graph. And the percentile rank ends up being, it says 18.498. But there's no such thing as the 18.498 percentile. We round it to the 18th. Now, if you used slightly different decimals, you might get 18.6, in which case you would just say the 19th. Is there really any difference between the 18th and the 19th percentile? Not really. No, they're close enough. Your new seat's back there. Thanks. I put you as far away from me as I could. Okay. Number 4. What would the arm measurement be for a male that is in the 12th percentile? So for number 4, over here I have 12%. So on the right, I would have 12%, which means in the middle, 12 and 12 is 24. The middle would be 76. Okay, I go to 0.76, which is 1.17. So Z is -1.17. What do I do with that? Need to turn it back into inches. So I multiply this by the SDX, 1.1. So -1.17 times 1.1. What does that tell me? Their arm measurement is 1.287 inches smaller than average. So I add that back to the average, 18.47. And this person's measurement would be 17.183. All right, that is all chapter 5. Okay, now we're going to go into chapter 10. Chapter 10 deals with X's and Y's at the same time. Oh, wait, hold on. We got some chapter 5 stuff left over. How many of the 50 students do we expect to be within 1 SD of the average arm measurement? So this was, Megan, was this your question you asked? The 68%? So we have our arm measurement, and if we go +1 and -1, we should capture 68%. So if I have 50 measurements, 50 times 0.68 is 34. So I would expect 34 measurements to be inside that window. Well, what is the window? The window is 18.47 plus 1.1 and minus 1.1. So 18.47 plus 1.1 gives me an upper bound of 19.57, and 18.47 minus 1.1 gives me a lower bound of 17.37. Now let's count them up. How many are there between this and this? And I put them in order for you to make it a little bit easier. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Pretty close, right? Now, how could we, I mean, we're off by 2. How could we have a higher percentage of accuracy? What could we do? I mean, 36 is pretty close to 34. But is there a way to increase the accuracy of our numbers? Measure more people. Yep. We only measured 50, which isn't a lot. If you measure more, then that number will probably be more accurate than it is now. Will it ever be perfect? Probably not. But it will be more perfect the more people we talk to. Okay. Number 6 is backwards. Let's do number 7. Let me take a picture of... Uh-oh. This isn't good. Okay. Now this should work. Nope. Maybe not. Maybe I won't take a picture. There we go. Yeah. So which one? 13. Yes. So number 13, change it to 17.5. 1.75 doesn't make any sense. Good eye. All right. Here is our scatter plot. I'm going to do 7 first because it's X on Y. So, number 7. If we know that a male has an arm measurement of 19 inches, what would be his expected leg measurement? So our point of averages is 18.5 and 21.8. So right here, let me switch colors. This point right here is 18.47, 21.8. And I want to know what is the leg measurement of a man who is at 19 inches. So basically, I want the average of this column right here. Okay, the way to do that is to figure out how far to the right we go. How far is it from 18.47 to 19? Plus 0.53 inches. But I don't want to know this measurement in inches. I want to know it in terms of the SD. So I divide that by 1.1. So 0.53 divided by 1.1 gives me 0.48. So to go from here to here, I did plus 0.48 SDXs, which means I need to go up 0.48 SDYs times R. And R in this case is 0.591. Why do I need to multiply it by R? Well, I have my football, and I have my SD line. That's not my SD line. Here's my SD line. And I also have this regression line. And that regression line changes. If my R value is 100%, then my SD line and my regression line are the same. But as R gets smaller, my regression line twists, right? So I didn't draw my SD line very well, but let me see if I can move my SD line a little bit. So if they match, I would go over one and up one. But when my R value gets smaller, my regression line twists and I don't go up 1 or 0.48 SDYs, I'm going to go up 59% of 0.48 SDYs. So I take my SDY and I times it by 0.591. And what does 0.28 tell me? That's how many SDs above average the leg measurement is going to be. So the arm measurement was 0.48 SDs larger than the average arm measurement, but my leg measurement is only 0.28. Now, 0.28 is smaller than 0.58. Is that expected? Yes, because of the regression effect. Right. The regression effect means the Y values are always closer to average than the X values are. Okay? So I need to do something to this 0.28 SDYs. I need to multiply it by the SDY, which is 1.45. Now what does that tell me? This is how big they are above average in inches. We just converted from SD to inches, so I'm going to add that to 21.8. And the person who is 19, has an arm measurement of 19, has an expected leg measurement of 22.2. Okay, let's do the same thing, but with number 6. If we know that a male has a leg measurement of 20.25, what would be his expected arm measurement? So my point of averages again is 18.47, 21.8. Where is 20.25? Well, it's going to be below the point of averages right here. Okay, so what is the distance from that line to the point? Well, it would be 20.25 minus 21.8. So 20.25 minus 21.8. Why did I subtract it like that? Where the number I'm looking for is below the SD, so I need a negative number. And I get negative 1.55. What does negative 1.55 mean? What unit is that in? Not yet. It's inches. 1.5 inches below average. I need to turn it into an SD by dividing by 1.45, and I get negative 1.068 SDYs. So this little blue line right here represents 1 SD below average. Now what do I do? Well, my slope is positive, so if my Y values go down, I need to take my X values to the left. I'm going to go left 1.06 SDXs times 0.59, which is R. So take that times 0.591, and I get a value of negative 0.63. What does that number tell me? That is how many SDs below average the expected X value is. I need to convert that back to inches, times it by 1.1, which is the SDX, and I get negative 0.6949. What is that? That is how far below average we expect the measurement of the arm to be in inches. So I add that to 18.47, and I get 17.7 inches. We getting the hang of this? Kind of? Are you glad we're doing this paper? All right. Number 11. So 8, 9, 8, 9, and 10 are, I think they're all kind of the same. 11. If a male is in the 29th percentile for arm, what is their expected percentile for leg? So we have the arm measurement. Where is the 29th percentile? It's on the left. So if this is 29 and this is 29, those add up to be 58. And 100 minus 58 is 42, so the center is 42. So I go to my area table. 0.42 is going to be 0.55. So my Z is negative 0.55. Okay, what unit is that in? 0.55 what? SDXs. Do I need to convert this into inches? No, because I know from my point of averages I'm going to go 0.55 to the left. So I need to go down 0.55 times R. So I multiply this by 0.591. Oh wait, I didn't have it in there. Negative 0.55 times 0.591. So that says instead of going down 0.55, I'm going to go down 0.325. Now what do I need? That's in SDYs. I need to do a shade norm to figure out the percentile for that SDY. I set up my leg measurement. Okay, and I know I'm going to be left negative 0.32, and I'm going to shade this. So clear out my draws, and then do a shade norm. And this is a percentile shade norm, so I'm going to keep it at negative infinity to negative 0.32. And it says 37.4%. So my answer is 37. I have to round it to the nearest percentile. So the answer would be 37th percentile. Now, is that expected? My original was the 29th percentile for arm. Are we expected to get a percentile for leg that is higher? Yes, because it's closer to the average. We're regressing toward the mean. All right. That should be everything you need. The last page is a little bit different because your R value is negative, but the idea is the same. So get to work.